Okay, Unit 5, Day 7. We're continuing on with our proofs today, and we're going to talk about some of the rules for isosceles triangles. You actually already know these rules. We just have to put them in the context of a proof. You will notice at the top of your notes, it talks about these two rules in here. When I say that you already know those two rules, that is because earlier in this unit we talked about how in a triangle, if you know that two sides are congruent, you also know that the opposite angles are congruent. And the rule is reversed. If you know that two angles are congruent, you know that the opposite sides are congruent. And I told you that having this picture as a vision in your head is going to be extremely important. We also have another reason today that we're going to talk about, which is that an isosceles triangle has two congruent sides. You already know that definition. It is also possible that maybe you would want to use this reason up here that says the base angles of an isosceles triangle are congruent. It's totally fine that you use this reason, but it means that you have to prove that you have an isosceles triangle first, and sometimes that takes more time. So you will very rarely see me use this reason. So if we look at question number 1, you can see that in question number 1, they are asking us to prove that MD and ME are congruent to each other. When we are asked to prove segments congruent, oftentimes it is the case that you want to make the triangles they are a part of congruent first. And I can see that in this picture, these two triangles are two triangles that are congruent. I'm going to want to make congruent to each other, so I can use corresponding parts of congruent triangles are congruent. So I'm going to back up out of here and make room for me to be able to mark up my picture a little bit. I'm going to have that note in the back of my head that before I prove these two segments congruent, I'm first going to want to make those two triangles congruent. So when I start this question and I look at the givens that I have initially, I can see that the first given tells me that I have side AC congruent to side BC. You will notice that those two orange sides are much longer than the part that we need to prove the triangles congruent. The little left triangle only has a segment that goes from A to D and a segment that goes from E to B that would be making up those sides. So they did not give me those orange sides congruent because they are sides of the triangle. They gave me those orange sides congruent because I'm supposed to use the rule up here that says if two sides of a triangle are congruent, the opposite angles are congruent. So for number 2 in my proof, I'm going to put in here that angle A is congruent to angle B because in a triangle, if two sides are congruent, the opposite angles are congruent. And that gives me a set of angles between my two triangles. Remember, I told you that the one thing we like about this isosceles triangle reason is it lets us convert congruent sides into congruent angles. If I continue on in this proof, my second given is that M is the midpoint of AB. So if M is the midpoint of AB, I know that I have these two segments that are congruent, one in each triangle. So I have AM congruent to MB. And that is from the second given, and we know that whenever we have a midpoint divides a segment into two congruent segments. And that gives me a set of sides between my triangles. If I go on to the next given tells me that I have AD congruent to BE. That in and of itself is a set of sides for the triangle. So when I'm looking at, at making those two smaller triangles congruent, I have all of the information that I need. My next step is going to be to go into the proof and write in here that my triangles are congruent. So this is triangle DAM congruent to triangle EBM. And the reason why my triangles are congruent, side angle side, congruent to side angle side. Once I know that my triangles are congruent, these two sides that was in my original proof line, they have to be congruent to each other. The reason why I now know that they are congruent to each other is because once the triangles are congruent, all of their parts are congruent. The formal reason for that is corresponding parts of congruent triangles are congruent. You use this reason after you make your triangles congruent to make all of the other parts congruent. For proof 2, I would strongly recommend that you try to do that on your own. Pause the video, try to do it on your own. And then if you can't and you need to come back and take a look at it, feel free, or you want to check it at the end. So if you'd like to pause the video now and come back, feel free to do that. I'm going to continue on with this proof. So in this proof, they give me in my first given that angle ADM is congruent to angle BEM. In this particular case, that does give me a set of angles. They also give me in the second given that DMA is congruent to EMB. That gives me a second set of angles if I'm looking at the two smaller triangles. In the next given, it tells me that EM bisects segment AB. So what this means is that AB should be getting a midpoint. Where EM goes along and hits AB, that should be where the midpoint is. So EM comes along and hits AB right here. That means that M is going to be the midpoint of AB. So M is the midpoint of AB. That'll be my reason 2. The reason why I know that I get a midpoint is because in line 2 I have a segment bisector, and a segment bisector creates a midpoint. So I say who the midpoint is and what that midpoint is the midpoint of, in this case segment AB. Once I know that M is the midpoint, now I can say that these two are congruent to each other. So my midpoint divided that segment into two congruent segments, giving me that AM is congruent to MB. Midpoint divides segment into two congruent segments. And as soon as I have that written in my proof, I now know that I have a set of sides congruent between the two triangles. At this point, I am able to see that based on the information that I have now come up with, I have 3 pieces of information. That means that I have enough to make the triangles congruent if it fits one of the patterns. And when I look, I have angle, angle, side congruent to angle, angle, side. So I can put in my proof that my two triangles are congruent to each other. So in this case, I'm going to put that triangle DAM is congruent to triangle EBM. And in this case, the triangles are congruent by angle, angle, side. And so we've kind of continued on our way making the triangles congruent. I have not yet mentioned this proof line. With this proof line, if I have to make the triangle isosceles, that's the big triangle, I have to make it isosceles, what I'm going to need to do is to somehow get two congruent sides. I want to get these two sides to be congruent to each other. The only way I can get those two sides to be congruent to each other, since they're not sides of the triangle, is to get this angle here congruent to this angle here. And then in my big triangle, if those two angles are congruent, then the opposite sides are. So that's my theory that I'm going to use here. But we have to talk, how are we going to get angle A congruent to angle B? Oh, that's right. We just said that those triangles were congruent in line 4. And once the triangles are congruent, all of their parts are. So I have angle A congruent to angle B because of corresponding parts of congruent triangles are congruent. So once I get those two angles congruent, I look at the big sides of this triangle, and I end up getting that side CA is congruent to side CB, because if two angles of one triangle are congruent, the opposite angles are congruent. And once I know that those two sides are congruent, if I was told that I had to classify this triangle that now has these two sides congruent to each other, my next step would be to say that triangle ABC is isosceles. If I have to give a reason, I would say an isosceles triangle has two congruent sides. So because this triangle has two congruent sides, it must be isosceles. So I've worked my way through that proof. In the first proof today, we said if the sides are congruent, then the angles are. In this one, we said if the angles are congruent, then the sides are. So a little bit different process here, question 2 than question 1. We worked backwards from the prior question. Now, question 3 is construction. So in question 3, with this construction, they're telling us that they want us to construct an isosceles obtuse triangle using the two side lengths. They're pretty specific in these directions by saying that they want it to be obtuse and isosceles. Isosceles means that one or the other of the two sides that are given are going to have to be repeated. Obtuse means that our angle has to end up being an angle that's more than 90 degrees. So if I look at what my potential can be for these two segments, I can use this one once and this one twice, meaning that I have two long sides. Whoopsie, hang on, I did that backwards. Two long sides like this and one short side. So this is side 2, this is side 2, this is side 1. My other option is I do it in the reverse order, which means I'm going to use two of these and one of these. So if I went through and did it that way, I would need one long one, and then I would need these two shorter ones like this. So I use this one is the one I used twice. This is the one I used once. So I can get two different triangles depending on which side I duplicate or which side I double. If I need an obtuse angle, this is clearly the way that I'm going to have to work this. So I want to use this side once and this side twice. And this is going to be my base. And these are going to be my two legs when I go through and do that. So that's the theory that I'm working with right now. So the first thing that I'm going to do with my construction is going to be that I am going to have to go in, pick up my compass and my ruler. That may take me a minute, so give me a second here. Did it show up somewhere? There it is. I just have to pull that down now, so maybe you'll need to get your construction tools out too. So here's my ruler, and then I also have to go in and get my compass. If it wants to cooperate with me. And again, they usually drop these off at the top of my page, so I've got to pull this down, I think. I don't know what the heck just happened there, but something did. Okay, so I had a little bit of a problem with my compass there, getting it moving, but I think I'm back on track now. When I'm going to construct an isosceles triangle, the first thing I need to do is I need to make a segment that is longer than whatever I'm going to use for the base. And please keep in mind, this was the second one was the one I was going to use for the base. So I want to go in, draw one that's longer than that. I'm going to take my compass. I'm going to line it up over here. Open my compass to the end. I'm going to make an arc that says I need my base to be this long. And then I'm going to take my compass and I'm going to move it over here, and I'm going to mark off that same length over here. My compass is a little fussy here. I can't get it right at the end. That'll have to be close enough. Okay, so here I've got a segment that's marked off the same length. And then I want to go back, and this time I'm going to measure how long this is, the smaller one. And remember, the smaller one I'm using is both the legs. So I'm going to take this. I'm going to mark off how big this one is. and this one is obviously much shorter. These are going to be the two legs. I'm going to say, okay, I need my two legs to be this particular size. My legs will start one of them here and one of them here. So I'm going to take that measurement on my compass, I'm going to put it at one end point, and I'm going to make an arc up here. And then I'm going to take it and I'm going to flip it to the other side. I'm going to put this here. I'm going to make an arc here. So now this point of intersection that I have here tells me where my two sides, the bases, the legs of this isosceles triangle are going to go. So I'm going to take my ruler. I'm going to line it up over here so I can get this one. No, that does not want to work right. Draw this in, swing it around. Now draw this one in. And when I'm done here, you're going to be able to see that my two legs that I've drawn are congruent to each other, and they are both meeting at that top vertex, so that my two legs of the triangle are congruent to each other. So there is my isosceles triangle. These two sides are congruent to each other. This angle that you have at the top here is obtuse. And because of the way that we've worked this, I now have an isosceles triangle that's obtuse as well. So you may need to practice that construction a couple of times. I have a little bit of trouble with the compass and the ruler. Sometimes they don't work as well on here as I would hope that they would. We can certainly go over this one more time in class just to make sure that everybody has this down.